Okay, my name is Micah Boland, and today I will be presenting my final project for the data mining course, and specifically my project is the analysis of smoking behavior using NHANES data. The purpose of the project was to determine whether demographic and health factors such as age, BMI, and blood pressure could predict smoking status. I applied uh, three different machine learning models, logistic regression, random forest, and lasso regression, and evaluated their predictive performance at the very end. So to begin, um, I loaded the necessary libraries. I used Tidyverse for data cleaning and visualization. I used Haven for reading the actual NHANES data sets that were brought over. Carrot for model training, and then Random Forest and Glimnet libraries were used for predictive models. And then I also use Proc to allow me to evaluate the model performance through ROC curves. And then I also set a seed at the very end to ensure reproducibility within these results as well. So as I go through and share my screen with the final project, just wanted to preemptively say that I'm using two screens. One does present the final model after it's been knitted from R Markdown, and then I have some notes over here. So if you see me jumping back and forth on screen, um, you'll know why. So data loading is this first section, and then kind of cleaning up some of the data as well was the first major code chunk that I used. So the NHANES collects comprehensive data health from nationally representative samples. For the project, I used four different data sets from NHANES, the demographics, smoking, body measurements, which is BMI, and then the blood pressures as well. So I pulled data from each one of those. And then the data sets were also merged into a participant identifier, which is the SEQN section of that, to ensure all relevant variables were aligned for each of the individuals involved. Next, I moved into and created a binary variable for smoking status specifically, where yes represents a current smoker and no represents non-smokers. I filtered out rows and the missing smoking status to ensure that the data was complete, and then also any values that were missing from the BMI and blood pressure were replaced with just the mean average to prevent any issues with model training going forward as well. I then did a little bit of data inspection based on some reading that I had done for this class, and then also outside the course as well from a different course as well. So I inspected the dimensions of the data set and confirmed that there were no missing values from the process, and ensure that the data was ready for the models that I was going to be running to explore the analysis. So the first section, here's one of the other ones, the call sums, and then the dimensions as well were the two that I was just speaking about. So as I go forward, we're now down here um, where I looked into some exploratory data based on smoking status. As I mentioned, separating the yes nos into different columns, which is here in this table. And then I ran a bar plot from the ggplot essentially to show the breakdown of the yes no answers. And the bar graph shows approximately 25% of the participants are smokers, while 75% are non-smokers. This shows that there's a class imbalance, which is consistent with the national prevalence rates, and it must be considered during the model evaluation going forward. So I just wanted to mention that as I went through. The next data that I pulled was the BMI distribution of smoking status. Essentially, what I was looking for with this was was there any relation of BMI based on the answer of smoking status, yes or no? So I ran a density plot to show this, and the density plot does show that smokers tend to have a less higher BMI than non-smokers, which does indicate that there is some predictability with BMI as a smoking behavior as well. I then went into a little bit of data splitting, briefly. So I split some of the data, excuse me, into training and training subsets, using 70% of the data for a training model and then 30% for evaluation to ensure that the model's performance are testing unseen data as well. Um, so the first model that I ran was the logistic regression. So I fit a logistic regression model using predictors such as age, gender, BMI, and systolic blood pressure. And the regression is pretty straightforward and provides interpretable coefficients for each one of the predictors, just as kind of some background. The findings from this ultimately, as I go down, showed that the model achieved an AUC as 0.58, as you can see on the table here, indicating that a moderate predictability is available. It also showed that age and BMI were the most significant predictors in this as well. Um, so going to the next model was random forest, as we can see here. Just Random forest is an ensemble that builds multiple decision trees and captures the complexity of relationships in its data, and then it also ranks the predictors by importance. Um, so as I scroll down to the AUC curve or the ROC curve, the AUC is at a 0.56, which shows in this as well that age and BMI again were the most important predictors in this model specifically. But the model was just a little bit weaker compared to the logistic regression. The final model that I ran was the lasso regression, and lasso applies regularization to penalize less important predictors. And this is to ensure that overfitting is prevented. So in this lasso regression, as I scroll down to the ROC curve, um, Lasso achieved a 0.50, indicating that there's no predictive power beyond just random guessing with this. And it suggests that the current set of predictors is insufficient to use for this method, honestly, because it's just you could randomly guess and probably get the exact same model that comes from this. So at the end of this model, or at the end of the project, I decided to run just a kind of bar graph of model comparison performance just to try to indicate if there was one outstanding performance over the other. The comparison highlights that logistic regression performed the best, followed by random forest and then lasso. Um, so it failed. Well, lasso failed to provide any meaningful prediction. The logistic regression was at its highest at 0.58, which indicates moderate predictability is available, but the overall feeling for these models is that they're pretty weak and don't provide a lot of predictability going forward with the research question and the hypothesis that I initially had. So with that being said, answering my research question, and we'll reflect on the research question, it's whether demographic and health factors predict smoking status. The analysis showed that while age and BMI are moderately predictive, the overall model's performance suggests that these variables are also inefficient just standing alone. The hypothesis testing, the null hypothesis stated that the demographic and health variables are not significant enough in predicting smoking status. Given the low AUC values of all the models, I failed to reject the null hypothesis as in this. And knowing this, what are the next steps to kind of improve on the model and what can be done going forward? To improve the performance, future studies should include additional variables. These variables could include stress levels, I found, education levels, physical activity, alcohol consumption. But I think overall, I think the four that I chose are kind of umbrella effects. If you found more variables within each one of those umbrellas, you could come out with better numbers for the smoking status within that. So just quickly in conclusion, the analysis demonstrates the challenges of predicting smoking behaviors with limited variables. I think it needs to be, as I mentioned, a more finite or specified variable that you look at and compare to and use to predict smoking status. I think age and BMI are both good general variables to use, but then you can even go forward with education level or even alcohol consumption to kind of determine a better outcomes for these models. But I think at least there was some indication from the age and BMI that those are two variables that could be used for future analysis. So thank you.